Hello. In this section, we extend our investigation of statistics and we look at ways that we make graphical displays of the data that we get. How do we do a little bit more computation, but then how do we display how the data is kind of spread out? So here we go. Here's the first scenario that we're going to work with. Let's say that I investigated the prices of 11 houses in the Helena area. Obviously, these prices are in thousands of dollars, and the prices of those houses are shown below. One thing we can do is we can compute what's called the 5-number summary, which is 5 values within the data set that kind of describe how the data set is kind of spread out. So the 5-number summary is obviously called the 5-number summary because it uses 5 numbers from the data set or within the data set. That's too far zoomed out. That's better. So if I look at the data set, the 5-number summary is as follows. The very first number in the summary is the minimum value. In this case, that would be $135,000. Let's jump over this lower quartile or quartile 1 for a second. Let's do the median because we know what that is. The median is the middle value in the data set. If you look, there's 11 values. That means that the middle is going to be the one which there's 5 above and 5 below. If there's an even number, I should mention that the median is the average of the middle too. So just to be aware of. So the median in this case is 230. Again, let's jump over the upper quartile or quartile 3 for right now and just talk about the maximum. The maximum value is obviously 500. Now let's talk about the lower quartile and the upper quartile. So lower quartile or quartile 1 is the middle number of the lower half. So it's essentially the median of the bottom half. So if I look at just the bottom half, what's the median of just the bottom half? It's right there. So this is quartile 1, so that would be 180. The quartile 3 is the median of the upper half. It's the middle number between the median and the maximum. Well, in this case, that's going to be 300. So there's your 5-number summary. We've got the min, quartile 1, we've got the median, we've got quartile 3, and we've got the max. You can kind of see why do they call these quartiles. Well, you can look and see we've essentially divided our data set into quarters. Here's the first quarter, here's the second quarter, here's the third quarter, and there's the fourth quarter. That's why you see the phrase quartile 1 and quartile 3. We're dividing our data set into the lowest 25%, the 25 to 50th percentile, the 50th to the 75th percentile, and the 75th all the way up to the 100th percentile. You can actually use a graphing calculator to get these values as well. I'll show you how to do that, and then I'll actually show you how you can do it in Desmos if you don't have a graphing calculator with you. What you would do with the graphing calculator is you turn it on, get to the main screen, and you go to where we went in the last section actually. You go to Stat, Edit, you type your data set in here. So if you have numbers in there, you hit clear, enter, and you type your numbers in. So what was some of our numbers? I won't type them all in, save some time, but 135 and then 150, 135, 150, ... You enter it all. Then you go back to Stat, over to Calculate, you choose option 1 and do 1 variable statistics. When you do that, this is what the output menu looks like. You might need to scroll down. There's the mean. We did that before, so the mean was $253.6 thousand. That's the average house price for those 11 sampled. If you scroll down to the bottom, the last 5 numbers in that list, there's the 5-number summary that we had. And you can look, there's the median. So the average house price is $253.6 thousand. The median is $230,000. How could you do this in Desmos? This is what you would do. So let me copy and paste this data set. So you go to Desmos. Again, you need to call your data set something. So D is a variable that's probably a good choice. So your data set is equal to, you need to use a bracket around data sets, and then you type in your data set. There it tells you you have 11 measurements. And then you need to go to the statistics keypad. So you go down here to the keypad, over to functions, and you need to do them one at a time. So first one's minimum, and then you say I want the minimum for data set D. There's the 135. Then you go back here, stat functions. Quartile. So the way that quartile works, it'll tell you, if you click over here, you need to tell it the data set, and then you have to tell it which quartile we're talking about. So D comma, first quartile. There's the 180. Then I go to functions. I want the median right there, median of D, 230. Then I go back and I want quartile again. This time I want the third quartile. So I do D, comma, 3. There's the third quartile. And then the last item I want for the 5-number summary is the max, max of D. There you go. There's your 5-number summary that we had before. 135, 180, 230, 300, all the way up to 500. Same exact 5-number summary. So you can use Desmos if you don't have a graphing calculator. Imagine though, so if you look at this case back here, look, the mean and the median were both fairly close to each other. They were both representative of the data set. Imagine though that I throw another house on there. I find a house that's worth $1.5 million, so that's $15,000. Imagine I toss that into our data set and I rerun the calculations. Well, look what happens. When I rerun those calculations, before there was our mean and our median value, look what happens afterward. My new mean, my average house price just jumped up $100,000. My median barely changed because the median just moved up a level. You'll notice, why is it 240? Well, because there's an even number of data values in my data set. This is where the median would be because there has to be 6 above and 6 below, and halfway between 230 and 250 is 240. So that's how you get the median if there's an even number of data sets in your data points in your data set. So look what happened. The mean changed a lot and the median barely changed. So if we add a $1.5 million house in there, do you think it's fair for me to say that the average house is $357,000? No, not really, because look, most of them are way below that. The median is still more representative of the data set. So the conclusion is this: an outlier will greatly affect the mean, much more than it will affect the median. So the median should be used if the data set has outliers, or as we'll see later, some severe skewness. But if there are outliers, the mean gets greatly affected by outliers. The median doesn't care about outliers because it's just going to move up, a step. It doesn't care how big, how expensive the most expensive house is. You could put a $50 million house here. The median would still be 240. So the mean is greatly affected by outliers. So if there's an outlier in your data set, you should report the median before you would ever report the mean. A graphical way of displaying the 5-number summary is making a box plot. In middle school, you might have heard this called a box and whisker plot. We've kind of dumped the whisker part of that, and we just call them box plots now. Box plots are just a visual way to display the distribution of a data set based on the 5-number summary. It's essentially a graphical 5-number summary. It's useful for showing skewed distributions. It's useful for showing how the distributions are, how the data set is spread out. When we make the box plot, this is what we do. We put the 5 points down on a number line. We put a box around the quartile 1 all the way up to quartile 3, and then we put a line where the median is. So this right here shows the middle 50%, because you'll see that a box plot splits it in the quarters again, right? So, right, there's my 5-number summary. This is the 0 to the 25th percentile. This is the 25 to the 50th percentile. This is the 50 to 75th percentile. This is 75th all the way up to the 100th percentile, 100% the way there. When we're putting a box plot around it, we are putting boxes around the middle 50%. That's what a box plot is doing. When you make a box plot, there are 3 types of distributions that you typically can get. You can get what we call negative skewness. So when a data set is skewed, what we mean is the tail is longer on the negative side. It means that these lower values are going to, actually what they're going to do is they're going to pull the average value down. They're kind of like outliers. So whichever side has the longer tail, or whisker if you think about it as box and whisker plots, the longer tail or the longer whisker is going to be the direction of the skewness. So since these lower values are longer, they're going to pull the average in the negative direction, so we call that negatively skewed. If the data set is fairly symmetric, we call it therefore a symmetric distribution. If it's positively skewed, what we see is that the tail is much longer on the right-hand side, and therefore these higher values are going to tend to pull the average up because the length of that tail is longer. It's skewed to the right. So it's going to positively bring the mean up. So what we're going to do is we're going to construct the box plot for the house price data that we had. We're going to remove that really high value of $1.5 million house, and we're going to construct the box plot for it. So make your number line and do it fairly, do a nice to scale. It doesn't need to be perfectly precise when you're doing it on your own, but make it somewhat to scale. Where the lowest value is 135, the max was 500, so my scale should be below 135 and above 500, so 100 to 600 looks good. Now my minimum is 135, and when you're making a box plot, you do not plot it on the number line. It sits above the number line. It hovers above it. So 135, so 150 is right in between. It's got to be a little to the left of 150, so maybe like right here. There's 135. There's my mean. 180 is not quite to 200, so maybe something like that. 230, well 250 is right here, so 230 has to be just to the left of that, so maybe right there. 300 is right here. Max is 500, right there. So there's my 5 points, and then how do I finish it out, right? We put a box around the middle 50%. We put a line where the median is, and then we extend the tails out to the min and to the max. It's also wise if you write the numbers above the 5-number summary. So you should put 135, 180, 230, 300, 500, because otherwise it'd be hard for somebody to know exactly what you were trying to communicate there. So that is how you'd make a box plot for this. You will see, so you notice this has positive skewness. This value of 500 is going to bring the average value above the median of 230. And you can see that if you go back to our data right here. Where it was right there. The mean is above the median because that high value of 500, this positive right skewness, brought the average value up. So this is positively skewed. That tail is in the positive direction. It will bring the average up. The actual average was around 250 if I remember. So the actual average value is like somewhere around there. It got brought up because of that 500 value. So slight positive skewness here. You can do it by hand. Doing it by hand is just as easy. I'll show you Desmos will do this as well if you're interested. So go back to this data set we had in there. It's already there because we called it D, and this is how you do it. You go back here to functions, stats, and it's under the distributions. You can choose Boxplot, or you can just type in Boxplot, and then you type a D in. It's on our scale. It's just, remember, it had high values. So if you hit this little magnifying glass, it'll fit the screen for you. And there you go. It'll readjust your scale. And then there is the picture that we had. So there's the box plot. So it'll make a box plot for you really quickly. I'm going to ask you to try. So here I have some data that came from a survey of high school students that were asked how much sleep they got the night before. So 17 high school students were asked how much sleep they got the night before. I'd like you to state the 5-number summary and then make a box plot for the data set. You can either use Desmos or your calculator. You can do it by hand, get the 5-number summary, and then make a box plot for that data set. I would bet this probably take a few minutes, probably 3-4 minutes. Pause the video, give yourself a chance to try, see how it goes. Unpause it once you want to see how it's done. So first thing you need is a 5-number summary. I use the calculator to get the 5-number summary. Here it is. So 4, 6, 7, 8, 12. And then when I graph the box plot, it looks like this. Again, I'd say this has a little bit of some positive skewness. This right tail is a little bit longer than the left, so I would say slight positive skewness, not quite symmetric. If it was right on that 10, it'd be perfectly symmetric. If it was even on the 11, it would be close to being symmetric. So slight positive skewness here. Another type of chart that we can make is called a histogram. You've heard them called a bar graph before. A histogram is a graphical representation as a bar chart of a data set where the data are grouped into bins. Just as box plots have skewness, so do histograms. If the tail is on the left-hand side, if the tail is longer on the left, just like in box plots, we call it negative skewness. That will bring the average value down. If it's symmetric, we call it symmetric. If the tail is on the right-hand side, that tail on the right will bring the average value up. So we call it positively skewed. When you are plotting the histogram, something just to be aware of, the mode is always going to be at the peak because that's the one that occurs the most. So the mode is at the peak, and then the mean is going to be the one the furthest to the left if it's negatively skewed, and the median has to be in the middle. Likewise, if it's positively skewed, again, the mode is going to be at the peak, The mean will be the furthest affected, so it's going to be the highest if there's positive skewness, and the median is going to be in the middle. So it always goes that the mode is at the peak, the mean is on the opposite side, and the median is always going to be in the middle for your histogram. We're going to make our own histogram with that sleeping data set. So make a histogram for the data concerning hours of sleep each night for the 17 high school students surveyed. So here we go. 4 to 4.9, how many were there? Well, there was 1. How many were between 6 to 6.9? 1, 2, 3, 4, 5. 7 to 7.9? 1, 2, 3, 4, 5, 6. How many got between 8 and 8.9? 2. How many got between 9 and 9.9? 1. 10 to 10.9? 1. There's the 11 cases, which is a 0, and this would be a 1. So there's my frequency chart. I'm going to use that then to make a histogram. So here we go. Let's say that this right here is going to be 4 to, was there a 5 in there? Let me see. Oh, I skipped that. So yeah, there would be a 5 to 5.9 as well, be aware. That would be 0. So 4 to 4.9. So, and then 5 to 6, 6, 7, 8, 9, 10, 11, 12, all the way up to 13. So in between 4 and 4.9 was 1. I can't remember if yep, so I'm guessing this is a tick mark right here, so 1, yep. Then there was 0 at 5 to 6, there were 5, so 1, 2, 3, 4, 5 up here between 6 to 7, 7.9 technically just below it. 7 to 8, there were 6, so 1 above that. Then 2, then 1, then 1, then 0, then 1. So there'd be my distribution, my histogram. You can see if I sketch a kind of general curve in there, it kind of looks like that. Might be some slight positive skewness. That right tail is just a little bit bigger. You can also, again, ask Desmos to make this for you. Going back to the Desmos, instead of doing a box plot this time, I could type in histogram, or if I go to functions, distribution, and do histogram, I can do histogram D. And if I hit this little button, it'll do a histogram for me. Let's get Boxplot out of there. I think we're going to want this. We need to decide, so you need to do the data set and then determine how wide the bins are. Oh, this wasn't our sleeping data. That's the issue. This was our house data set. So let's do a different graph for that. Actually, I think I saved it. I did. Good, I was clever. Just to show you it. A sec. So there's our sleeping data, histogram, and then you type in the data set, and then if you hit the little zoom button, it'll scale it for you, and there's our histogram. So you can use Desmos to do it as well. You just need to do histogram and then type in the data set. And then at the end, there's a little comma button. You can determine how wide you want your bins to be. We had them to be 1 wide. So is it positively or negatively skewed? I would say it has maybe just slight positive. It's very slight, but just barely. So slight positive. There's a little more on the positive side than the negative side. And that's it for today. Thank you very much, and have a good day.